In this video, let's take a look at the line angle structure for a hydrocarbon that contains an alkene. For organic chemistry students, the alkene functional group is this carbon-carbon double bond. So we're looking at the line angle structure. Let's convert this into a Lewis structure. This is a hydrocarbon. Hydrocarbons are molecules with only carbon and hydrogen atoms present. You'll notice zigzag lines. Every end of a line and corner represent a carbon atom. And the lines between the corners and end of a line represents a covalent bond. Let's convert this into a Lewis structure. At the end of the line, we have a carbon atom. This goes up to another carbon atom. This comes down to a carbon atom. And then we'll go back up here to the end of a line, which is a carbon atom. We also see here an extra line, and so that represents that pi bond or that extra bond between carbon atoms. The next rule is that if there are heteroatoms or atoms other than carbon and hydrogen, then their elemental symbol must be present. Since I've already said that this example is a hydrocarbon, there are only carbon and hydrogen atoms present. The next rule is that we can assume there's enough hydrogen present to satisfy the octet rule for carbon. Another way to think about this is to make carbon tetravalent, or give carbon 4 bonds. The carbon at the end has 1 bond, so we'll give it 3 other bonds. There's 1. Notice I drew this in the plane. This carbon has 2 other hydrogens and it carries a tetrahedral geometry. So I'll go ahead and draw my other hydrogens like this, one in a wedge. This wedge represents this atom is coming out of your screen towards you, and this atom in dashes is going into your screen. Interestingly, the 2 carbons in the center, each carbon has 3 bonds. So how many hydrogens go on this carbon? 1 more. Notice I'm drawing this in the plane, so the line represents an atom in the plane, and that's because this carbon is sp2 hybridized. This carbon right here has a trigonal planar shape around it. So this is flat on the paper in a triangle shape. And the same for the 3rd carbon. Notice that the carbons are all tetravalent. We can go ahead and close this last carbon with that hydrogen, and then we want to give it 2 more hydrogens to give it 4 bonds. Again, just for geometry purposes, I'll draw this with the wedge and dash bonds. You don't have to draw the wedge and dash bonds unless your instructor asks you to. You can draw those in just lines just to show the 4 bonds on the carbon. And so this is the line angle structure for this molecule. This is the Lewis structure. Let's go ahead and build it so we can see it with the models. So I'm zooming out just a little bit so we can see the structures and the model. So here's the model. You can see here that zigzag shape. And so that's why we draw line angle structures with a zigzag shape, so we can get some idea of the geometry. Of course, the geometry around the tetrahedral carbon right here at the end, those bond angles are 109.5 degrees. The bond angle around the trigonal planar is 120. So they're pretty close to each other. We can draw the zigzag lines to represent that geometry or bond angle. Here's your double bond in the center. You can see the double bond right there. If I turn this molecule 90 degrees, you can see that it's flat around these two atoms. Of course, the carbons at the end have that tetrahedral shape. And so you can see the line angle structure with the zigzag shape. It really does resemble our model.